Hello my friends, sorry I couldn't be there today, but I put together this video to help you learn about compositions of functions, so hopefully this will help you until I get back. So as always, start by highlighting your titles please, and then off we go into the wonderful world of functions and compositions of them. So first of all, this f of x here, I'm going to make a little bubble that teaches us about f of x. We've got x's and we've got y's. The first x-y pair is -4, -5. The next one is 0, 3. And finally we have 1, 6. And that is our f of x bubble. Similarly, we have our g of x function, which has x's and y's. 6 goes to 1, -5 goes to 0, and 3 goes to -4. So that's what's happening there. So what we're going to do is we're going to take f into g and g into f and play interchangeably with them. So the first thing we're going to do is find this, which the notation looks a little bit crazy. The way you read that is f circle g of x. Some people call it fog, but really all it means is f of g of x. So like yesterday we were practicing putting a number inside of f. For example, if I have f of x equals 2x plus 5, and then I ask you to find f of 2, for example, then everywhere you see x, you're going to replace it with parentheses, and into those parentheses you're going to substitute 2. Well, in this case, into my parentheses for every f, I'm actually going to substitute all of g of x. So you always start inside and you work your way out. So we're going to take g of x and substitute that into f. So for example, we're going to have f of the first g of x point is 6, 1. We're going to find out what that means in a second. F of the next g of x point, which is -5, 0. And the last g of x point, which is 3, -4. Alrighty. So in my g of x bubble, you can see that 6 goes to 1. And then the question is, if I start at 1, where does f take that? And f takes that to 6. So that means that we can follow this pattern. 6 goes to 1 on the g part of it, and then I'm going to put that inside of f, and f takes that 1 and makes it become a 6. So all together now, this goes here from 6 to 6, which means that this is equivalent to 6, 6. Let's do that a couple more times. Okay, so now we're going to follow from -5. -5 goes to 0 in the g function, and then I'm going to put that into the f function and see where that 0 goes. And 0 goes to 3. So in the g function, -5 goes to 0, and then if I put that into f, it finishes off in 3. So again, from start to finish, that's -5, 3. And one more time like that. We're going to start with 3 goes to -4. Sorry about that. And then that's in the g. If I put that into f, it's right here, and it finishes off at -5. So in g, 3 goes to -4, and then once I take that to f, the -4 goes to -5. So in total, this ordered pair becomes 3, -5. So altogether, the final answer for f circle g of x, also known as f of g of x, if you want to call it that, you can call it either of those things, is all of those purple ordered pairs. And again, we're going to put them in braces because that means I'm about to list everything and there's nothing else. So 6 goes to 6, negative 5 goes to 3, and 3 goes to negative 5. Close your parentheses, and that is the first half of the question. Because the first half asks us to find f circle g of x. The second half of the question asks you to go the other way. Go g circle f of x. And I'm going to try to figure out how to move this stuff without erasing it so you guys can still see f if you need to. But of course, this is a video, so you can pause and go back and rewind and review as many times as you need to. So let me scoot that up. And then we're going to go the other way. So this time, we're going to go, instead of f circle g of x, we're going to go g circle f of x. So g circle f of x is the same as g of f of x. And so this time, always starting from the inside and working your way out, this time we're going to start with f of x. So we're going to follow the order that f takes us and then put that inside of g. All right, so I'm actually going to erase our previous work so that we can have space to do the second part of this problem. All right, so we have g, and then the first f point is negative 4, negative 5. We'll see where that takes us. Then we're going to have g of 0, 3, and see where that takes us. And the last point on f is 1, 6. So again, you always start, sorry about that, you always start inside. That's what goes into all of those parentheses, and you work your way out. So starting with f of x, we're going to follow this and see what happens. Negative 4 goes to negative 5 in the f, and then into g from negative 5, we finish off at 0. So this ends up working like this. Negative 4 goes to negative 5 in the f, and then when I put that into g, it ends at 0. So from beginning to end, that is negative 4, 0. Okay. Likewise, trying to erase these things without erasing everything. The next one, we're going to go from 0 to 3 in the f, so 0 goes to 3. Then we find that on the y and finish it off. So 0 goes to 3 in the f, and then once I continue that path into y, it goes to negative 4. So from beginning to end, that's 0, negative 4. And one more time, this time we're going to go from 1 to 6. I tried. From 1 to 6, we go here, and then we follow 6 into the G bubble, and we end up at 1. So 1 goes to 6 in the F, and then G takes that 6 to 1. So from beginning to end, if we plug them into each other, 1 actually ends up going back to 1. So for your final answer for G circle F of X, also known as G of F of X, is just all of those ordered pairs. Negative 4 goes to 0, 0 goes to negative 4, and 1 goes to 1. And that is the second part of the answer. And I'd love to ask if there's any questions, but I'm not there to hear your answer. So if you have questions, just replay that again. All right, so we're going to go again on example 2. Same thing. We're going to do F of circle G of F circle G, and then we're going to do G circle F and play back and forth on these two things. I'm going to erase these so we have space to work. All right, so we have f of x now a new set of points and g of x a new set of points. And we're going to start with f of g of x. f circle g of x, also known as f of g of x. And whatever's inside is what you start with. Always start inside and work your way out. So we're going to apply f to the points on g, -2, 0, and 3, 4, and 5, -2. So following from -2 to 0 on the g, that's this part. And then I find 0 on the f, and it's here. So that 0 ends up going to -2. Hopefully you guys are following that without the bubbles. That ends up being -2, -2. If you need to, you can create bubbles like I did on the previous example. But if this makes sense to you, then go with it. All right, for the next one, we have 3 goes to 4 in the G, that's here. Then I find where 4 keeps going in F, it's right there. 4 goes on to become -5. So all together from start to finish, that's 3, -5. And then one more time. The last one goes from 5 to -2. That's this one. And then F takes -2 and turns that into a 3. So from start to finish, that's 5, 3. All right, so I'm going to erase the previous problem for space purposes. And our answer for the first half of this question, f circle g of x or f of g of x, you don't have to write both. You can pick which one makes more sense to you. Either one of those, the answer ends up being all of our order pairs, but we're going to put them in braces because that means this is it and there are no others. So -2 goes to -2, 3 goes to -5, and 5 goes to 3. Don't forget to close your braces. So that's the first half of the question, f circle g of x. And then next we're going to go backwards and go g circle f of x. Scoot this over here. And start again. We got g of x and f of x. This time we're going for g circle f of x. So g circle f of x, which is the same as g of f of x. We start inside and work our way out. So the inside is f of x. We're going to put that inside of g. So we're going to find g of the first ordered pair, -2, 3. G of the second pair, 4, -5. And g of the last pair, all of these are coming from f, 0, -2. All right, so at the top there, -2 goes to 3, that's this guy. And then we find where 3 starts on G, and that's here, and it ends up going to 4. So this goes -2 to 3 to 4. So that's all good and fine and dandy, -2 and 4. On the next one, we have 4, -5. And then I figure out where -5 goes on G, but I'm not seeing a -5 on G. So this one is actually impossible because yes, 4 goes to -5, but then G never takes it anywhere. So where does that go? We don't know. And we can quit right there because as soon as one's impossible, the whole thing's impossible. So actually other way around. G of f of x is impossible. If one or more of them have nowhere to go, then we can't complete the question. So both of these are for number 2. And again, I'd love to ask if you have questions, but I wouldn't be able to hear you. So hopefully that makes sense. And we're going to move on. But if you need to see that again, feel free to replay as many times as you need. All right, down here, we've got new functions. We've got f of x is x plus 5, and g of x is x squared plus 5x plus 3. And we're going to be substituting them into each other, just like we were doing on the previous examples, except in the previous examples we had specific numbers, and now we're going to be working with variables, but the idea is the same. So first of all, f circle g of x is the same as f of g of x, and you always start inside and work your way out. So we're going to leave the outside for a second and substitute in our g of x, which becomes x squared plus 5x plus 3. All this, substituting in there. Now, I'm going to take that whole thing, and every time I see x in the other function, for example, right there I see x, I'm going to replace x with all of that. So in order to substitute into f, I'm going to replace all the x's with whatever's inside of those f parentheses. So that happens to be a long polynomial, and we're going to substitute in that whole thing. So all of this x squared plus 5x plus 3 is replacing this x. Outside of that, I still have this plus 5, so we're just going to add that on to the back. And finally, your answer is just that after you've combined like terms. So x squared plus 5x plus 8 is your FOG, or your f circle g of x, or your f of g of x. Okay, now we're going to go the other way. Just clean this up here. All right, on this next one, we're going g circle f of x, which is g of f of x, and you always start inside and work your way out. So I'm seeing an f of x in here, so I'm going to start with that, replace f of x with everything that it is, which is x plus 5. And the g is still outside, haven't done anything with that yet. But what that means is now I'm going into g, and everywhere I see an x, which I see one in the front and I see one in the middle, both of those are going to become this whole thing, whatever's inside the parentheses. So every time you see parentheses on the g function, every time you see x, you're going to put parentheses instead. So parentheses squared plus 5 times parentheses, and then the plus 3 in the back. And into those parentheses, we're going to substitute this x plus 5 both times. So x plus 5 and x plus 5. On that first set, you cannot distribute the squared. That does not work. Instead, you have to write the whole thing twice and distribute everything to everything. So x plus 5 times x plus 5. On the second one, we can just distribute there. So 5x plus 25. And then finally, we've got that plus 3 hanging out in the back. Again, got to distribute everything to everything. So x times x squared, x times 5, 5x, 5 times x, 5x, 5 times 5, 25. And then bringing this 5x down, we can combine these like terms in the back. And finally, we combine all the like terms. Make sure your final answer is in standard form, highest exponent to lowest. So we got this guy, x squared. Then we've got 5x, 5x, and 5x. That gets me 15x. And then I've got 25 and 28, which makes 53. So after all that, g circle f of x, or g of f of x, turned out to be x squared plus 15x plus 53. Scoot this stuff over so I have space for my last question. Like so. All right. So you don't have to substitute them into each other. You can actually substitute them into themselves, as you can see on this last example, where we're going to put f inside of f, which is interesting, but we're going to do it. All right, so f circle f is the same as f of x. And again, we always start inside and work our way out. So on the inside here is f of x. Let's write that down. It's x plus 5. On the outside, I still have an f there. And now every time I see x, I'm going to replace it, but notice I'm going back into f again. So wherever I see x, which there's only one, I'm going to put parentheses, and into those parentheses we're going to substitute what we just substitute inside of there, this guy. And then notice there's still a plus 5 on the outside of that, so plus 5. And simplifying this much faster than the previous one, your answer is simply x plus 10. So that is called composition of functions, when you substitute functions into each other. If you're given points, you're following a path. -4 goes to -5, and then I find that and keep going. If you're not given numbers, if you're given functions instead, you're just substituting them into each other. Every time you see x, you replace with whatever is inside of that function. So hopefully that makes sense. And if it doesn't, watch this video as many times as it takes in order for it to make sense. Hope you guys are doing great, and hope I get to see you soon. Take care.